Hey Calculus kids, this is Dr. Callahan. Welcome to week 6, Thursday. Pause the video to finish your warm-up. All right, so today we're going to go over instantaneous rate of change, or basically it's kind of like the slope formula, if you think about it. The slope formula is rise over run, and it is a rise over run between two different points. So here I have point 1 and point 2. And with these 2 points, in algebra, you learn that this is x1, y1, this point is x2, y2, and the slope formula is as follows. y2 minus y1 over x2 minus x1, which is rise over run. If you think about it, this right here is your rise, and here is you running over. Well, in calculus, we don't use x1, y1, we use f of x. So x here is the x value, y value is the f of x. Now if you look at this point, as you're running over across from point 1 to point 2, there's a little bit of a change right here, which we're going to call delta x. So then your new x value for point 2, and this is your second point, is going to be x plus delta x, because here's your x and you're running over, plus the delta x, comma, your y value is f of x plus delta x. Okay, so let's go ahead and proceed forward. Make sure you guys are completing the assessment on Wednesdays. Every Wednesday, you guys have an assessment. We don't have tests or quizzes in this class. It's just an assessment. And this week, it is on AP College Board. So make sure you guys log on to that. And it's 2 parts. First part is multiple choice. The second part is free response. From the free response, there are 3 different varieties that you can pick from. You just need to select one. You have exactly 1 week to complete that, and so that will be due, I'm sorry, not 1 week, you have until Sunday to complete it. So for your assessment for week 6, Wednesday, make sure you guys go to AP College Board, log on, it's important that you do that. You do, however, need to have a class code, which is also posted on MS Team. This is really important because if you do not log on to College Board, they will not order your AP Calculus exam. We don't do the paper formatting anymore. Everything is always going to be online from now moving forward. Make sure you guys look for week 6 Wednesday, and there are 2 parts of the quiz. The first part is assessment, multiple choice question. Second part is a free response question, and you just need to pick one of them. This is due on Sunday by 11 p.m. I always usually pass back your assessment within 1 week of taking it. It probably will be a lot sooner than that. Why do I do that? Because if I hold it on to any longer, students generally tend to lose interest in the relevance of the test and the grade after 2 weeks. Your grades will be updated on Infinite Campus. If you're not satisfied, you're welcome to do the test correction. You can find the template on my Google Doc page. If you do need to have some assistance with after-school tutoring, we do have after-school tutorings on Tuesdays, or excuse me, on Thursdays, right after school in C2 with Mr. Pacheco. And I'm also going to be offering Zoom hours as well. That's something that you guys can do, so stay tuned for that. Unfortunately, I cannot go any slower for you, mainly because I've already paced out what we're going to be doing between now and the day of the AP exam. And if I go any slower now, that means when we get to the more difficult concepts, we won't have enough time to justify not spending that time wisely on those concepts. So make sure you are preparing yourself ahead of time for class. You have your packet, your notes from, pretty much like 3 or 4 weeks at a time. So my recommendation is make sure you read your notes ahead of time so you are prepared for class. Your AP exam is timed, so you do also need to work on strategies. So I'm not just going to be teaching you guys the content, but also strategies on how you can save time on the AP exam. Last year, I had several students, I got a 5, which is a perfect score on it. And the number one recommendation they said they did was that they definitely prepared ahead of time and they didn't procrastinate to the very end of the semester. You do have plenty of material of how to go about studying for this. You have weekly summarized notes. You also have the video notes, Khan Academy Online. You have the study guides with answers that I provided. You have my website. You have the Google Doc. So this really is a standard or the bar to this class. My philosophy in life is there's only 24 hours a day. We have to learn how to study smarter, not necessarily harder, because you can't really surpass the 24 hours. If you need to go ahead and do the test correction, here is a template, and here's an example of how somebody else did this. All right, go ahead and turn over to your notes today, which is going to be on week 6, Thursday. Here's some practice problem for you guys to go ahead and practice with after today's lesson. This is your guided note that we're going to go over with the 3 examples. These are my notes that are typed up, so you might want to read them. So we can go ahead and reserve the class time specifically to doing the examples in class. This is your objective. Go ahead and read them as well. I do have a Quizlet flashcard activity right here. In calculus, we have a lot of vocabulary, so make sure you take a look at that. All right, so first things first. The slope of the red line represents the average rate of change, or in this case, it's the average case of speed. And then you have a tangent line and a secant line. A tangent line is a point on a graph where it represents slope. A secant line essentially is just 2 points. How do you find the slope of a secant line? Generally, you would use a slope formula, which is the y2 minus y1 over x2 minus x1. How do you go about finding the slope of a tangent line with one slope or 1 point? It is the same formula as a secant line, but there is a limit, and that limit is represented by the delta x. So delta x is the change of x. If you have 2 points, and these are the 2 points from the secant line, here is x1, x2. For me to get from this first point to the location of the second point, there is a change of x, or we call it delta x. So if this is my first point, x, f of x for y, and that's my first point, my second point is going to be x plus the delta x, because you're shifting this point over to the right. And then my y value for the second point is f of x plus delta x. Now, if I were to apply this into my formula for slope, because this is x1, y1, x2, y2, remember your slope formula is y2 minus y1 over x2 minus x1. Well, if I replace this with these points, but instead of using y and x, I'm using x and delta x. Y2 is f of x plus delta x minus y1, which is f of x, divided by x2, which is x plus delta x minus x1, which is just x. Well, if you take a look at this here, the x's cancel. And this is your formula, f of x plus delta x minus f of x over delta x. This is the limit definition formula. And we're going to be using that today in the 3 examples, and that's going to help us move forward when we talk about derivatives. So once again, looking at this part here, 2 points, x1, y1, x2, y2. This is your slope formula. How do we get from here to here? Well, I just did explain that to you, but one more time, this is your x2, f of x2, x1, f of x1. When you're moving this point to meet the second point, you're going and shifting that point over. When you shift it over, it is going to have a change of x because it's moving a little bit further to the right. So it's called a delta x. And then when you go ahead and plug that into this formula, you have x plus, or excuse me, x f of x plus delta x, comma, f of x plus delta x. And you plug this into this formula, you will eventually have this. But then we also have a limit. Delta x approaches 0. Because if I eliminate this, it's going to give me the slope, or f prime of x, or derivative. So there are different formulas and symbols when it comes to derivatives. I'm going to show you all of them. So it could be f prime of x, dy over dx, y prime, d over dx of f of x, capital dx of y. I know it just keeps going on, but all of these all means derivative. All right, let's now go to the example. I know that was a pretty long build-up of getting here. All right, so it says given the value f of x equals x squared, find f prime of x using the limit definition. Then find the value of the derivative at point -1, comma 2. So looking at this, I am going to start off with f of x plus delta x. Here's my equation. Whenever there's an x, I'm going to replace that x with x plus delta x. So x plus delta x squared plus 1. Well, I will have to FOIL this. So if I FOIL this, FOIL, I will have to rewrite this as x plus delta x times x plus delta x. First is x times x, so x squared. Outer, x delta x. Inner, x delta x. Last, delta x squared. If I combine the two together, that's going to be a 1 plus a 1, which is 2x delta x. And so my answer here will be x squared plus 2x delta x plus delta x squared. Don't forget your 1 plus 1. Next part is a negative f of x. Negative f of x means I just simply change the signs. So negative x squared minus 1. So make sure you tag that along. Negative x squared minus 1. And this thing is all the way over delta x. Well, let's go ahead and simplify this a little bit. X squared cancels. 1 cancels, and I am left with 2x delta x plus delta x squared. Well, I can factor out a delta x out, so 2x plus delta x. Cancel the delta x, and I'm left with 2x plus delta x. So here is my derivative of the limit as x approaches 0. So when x approaches 0, this becomes a 0. So what is my answer? 2x. That is my slope. So you think you're done, but you're not done yet. Okay, it says find the value of the derivative at this point. So I'm going to do f prime of x is -1, equals 2 times -1, which is just -2. And that, boys and girls, is my answer. Woo-hoo. All right, let's go on to the next one. Okay, if I were to visually think about this formula here, the f of x equals x squared plus 1, is going to be this blue line right here. Okay? And then my derivative is going to be at -2x, okay? Equals -2x. At this point, -1, 2, which is right here, my slope from this point is you're going to go from this point here, you're going to have a slope of I just lost my train of thought. I'm sorry. Okay, so let's go back to this. What does the blue line represent? It represents the equation f of x. What does the red line represent? The red line right here is going to represent the tangent line. The tangent line is going to have the point at -1, 2. So here's -1, 1, 2. There is your point. Okay, and there's your tangent line. What is the slope of the line? Does it match f prime of x? Well, this is definitely a negative slope on this red line. And remember, your slope is supposed to be a -2. So is this one going down 2 over 1? Yes, it is. Down 2 over 1? Yes, it is. What does a green line represent? Excuse me. Equation of the derivative of f prime at 2x. And that makes sense because it is a positive 2x. You're going up 2 over 1, up 2 over 1. Okay, example 2. All right, so let's go ahead and use the limit definition. We are going to follow along with this. Okay, so what we're going to do is we're going to start off with the first part right here. So f of x plus delta x is equal to, and I'll put that in here, square root of x plus delta x. Well, that was a lot easier than before. Minus f of x is going to be a negative delta x. So I'm going to have x plus delta x minus delta x all the way over delta x. Let's go ahead and apply the limit. Limit as delta x approaches 0. If I do direct substitution, I will have a 0 in the denominator. So what do? Yep, you guessed it. We will now have to go ahead and multiply by the conjugate. So I'm going to multiply the top by x plus delta x plus square root of x, denominator x plus delta x plus square root of x. Most likely I'm going to have to FOIL the numerator. So FOIL. First is just going to eliminate the square root. Outer and inner. Outer is going to give me n square root of x times x plus delta x. Inner is going to give me a negative version of that, which is great because I can cancel it. And then last is just going to give me a negative x. These two cancels. X and negative x cancels. And wow, I'm just left with delta x over delta x times square root of x delta x plus square root of x. So now let's go ahead and take a look at this. I can now cancel the delta x. I have a 1 on top. Now that the delta x is gone, let's apply the limit. So as x approaches 0, that becomes a 0. That becomes a 0. I'm going to have 1 over square root. Or actually, you know what? I actually put in the 0 in the wrong spot. Here we go. Get rid of that. This. Because this is a delta x approach 0. So this becomes a 0. And we'll have a square root of x plus a square root of x. The coefficient is a 1 in front of it. So my answer is 1 over 2 square root x. F prime of x. Don't forget your last part, which is a 0.11. So f prime of 1 is going to be 1 over 2. And that is my slope. So let's go ahead and confirm this with the graph. If I were to graph this, my blue line is going to look like this. This is my f of x, which is square root of x. Then I have the red line, which represents the slope of the tangent line at 0.11. So 1 is right here. And if you look at the slope of this red line, my slope that I found was 1 over 2. So am I going up 1 over 2 for the next point? Yes, I am. Up 1 over 2, up 1 over 2. Example 3. I'm going to have you guys try example 3 on your own, but I am going to give the answer. F prime of x is going to give you a negative 1 over x squared. So give that a try. All right, you guys, I hope to see you guys next time. Take care and stay safe.